Cool. Hey guys, great to be here in Brazil. Unfortunately, I don't speak Portuguese, so that last talk sounded like it was really good, but I didn't quite get some of the jokes. Sorry? Oh no, it's okay, thanks. So I'm going to be talking to you all about unit testing of Vuex store, and I'm going to show you 3 different approaches you can use to unit test a store. So my name's Edd Yerburgh. I'm a software engineer at the BBC in London, and I'm also the main author of Vue Test Utils, which is a testing library for Vue. So hands up if you've written a unit test before. Okay, cool, pretty much everybody. For those of you who don't know, a unit test is basically a piece of code that calls another piece of code and then somehow reports back whether that code behaved as expected. So I've got an example function up here, a sum function that takes 2 parameters and returns the sum of those parameters. So imagine we want to check that this is working correctly. And we could do this with a unit test. So here we're using a test runner called jest. And with jest, you define a test with the test function. You give it a spec name. We're checking that it returns the sum of its input. And then we have the actual test function itself. And in there, we can write an assertion using an expect function. So here we're expecting that the sum of 1 and 3 will equal 4. So if the sum of 1 and 3 returns 4, the test will pass. If the sum of 1 and 3 doesn't return 4, then the test will fail. So that's what a unit test is. Okay, so why should we write unit tests? One of the reasons is that unit tests help you check that your code's working correctly, which is pretty useful. It saves you time over manually testing in the browser or just not testing at all. Another benefit of unit tests is that they document your code. So when you write a unit test, you're writing down a specification for how your code behaves. And that can be really useful for new developers who come to a project and they want to see how a unit works. And finally, unit tests enable workflows, specifically TDD, test-driven development, which is a workflow where you write your test before you write your code. So without tests, TDD would just be DD, which doesn't really work. So that's what a unit test is. I said we're going to unit test a Vuex store. And Jacob gave a really talk earlier about Vuex, so I'm sure you guys are all clued up about what it is. He actually told you not to look at this diagram, but I have it on a slide anyway. So this is like the Vuex flow, but we're just going to be focusing on the store, which is this part. So if we take a closer look, you can see that the store is made up of actions, mutations, state, and getters. So it states the actual data of the application, mutations are functions that update the state, actions are asynchronous functions that can commit mutations, and then you have getters, which compute values from the store state. So we're going to write some tests for a Vuex store, and as an example, I'll show you how to write tests for a simple web app that fetches some data from the Reddit API, saves it in the store, and then renders using that data. But as I said, we're just going to be focusing on the store part. So the store flow isn't going to have any getters. We're just going to have a fetch items action that fetches data from the Reddit API and then commits a set items mutation that then updates the state items value. So we'll write a test for this store flow. So I already said that there's 3 approaches to testing, and I'll walk you through each one. The first one might be a bit surprising because the first approach to testing a Vuex store is that you don't test a Vuex store. So this is a homemade meme that Eduardo helped me make earlier. Yeah, so although tests are pretty much always a good thing, you know, they save you time and they help document your code. This isn't always the case. Tests aren't free. You have to spend time writing them and you have to spend time maintaining them. So if you end up spending more time writing your tests than you save yourself, or the benefits you get from having tests, it might not make sense to write any. So, for example, if you were just maybe writing an internal tool where you're going to do a lot of development in one burst, manually test it a lot, and then not do any development at all, I think it might make sense to not write any tests. But obviously that's a little bit of a cop-out. Oh, it's that meme again. So, the second approach is to test all the store parts separately. So remember that we have these actions, mutations, and getters, and Jacob was saying all of these are just functions. They're just methods. So we can just write unit tests for each of these parts separately. I'll show you what that looks like. So here's a set items mutation, and it's ridiculously simple. It takes some state, and then it takes some items in a payload object, and it just sets the state items value to the items passed in the payload. So if we wanted to test that that was working correctly, we're going to write a test that checks that when we call the mutation with those parameters, it updates the items value. Pretty simple. So the test would look a bit like this. We're going to define a test, create a fake state object, create some items that we'll pass in the payload object, and then just call the mutation with those values. And finally, write an assertion to check that the items value is updated to the items passed in the payload object. So you could write lots of tests like this for mutations, and they're always going to pretty much look like this, because ultimately a mutation updates the state value. It's a little bit more complicated when you're talking about actions, because they're often asynchronous functions, and also they're usually asynchronous because they're making HTTP requests in another file. When you're writing unit tests, one of the golden rules of unit tests is that you shouldn't make HTTP requests in them, because it slows down your unit tests and it makes them unreliable. They're not always going to produce the same result if there's an HTTP request. So you can see here we have a fetch items action, and it just takes it extracts commit from the context object that it's called with, and then it calls this fetch data function. And with the result of the fetch data function, it commits set items. So if we were going to test this, we would have to do two things. We need to somehow control the data that's returned from the fetch data function. And we also want to make sure the fetch data function doesn't make an HTTP request. And luckily, we can do that with jest. So you see that there's this jest mock call that I'm making. And I'm passing in the path of the API file. What that's going to do is it'll tell jest to intercept any imports of that file with a mock file that contains the same methods as the original file, but replaced with jest mock functions. And jest mock functions are really cool because we can control what they return. So we could set the fetch data function to resolve with this items array, rather than to use the original fetch data function, which makes an HTTP request. So once we have that mocked, we basically are going to check that we call commit with the correct arguments. So we'll create a commit mock function. So a mock function is a function that records data about how it was called, and we can assert that this was called with the correct arguments later. And then we just call the action and use await because it's asynchronous, and then just expect that commit was called with the correct arguments. So that's a simple unit test for a really simple action. You can already see there's quite a lot going on, and you can imagine as the action gets larger, you're going to have to do a lot more mocking, and it's going to be quite difficult to follow the unit test. So the key characteristics of testing store parts separately is that firstly you get really fine-grained tests, and what that means is that your tests are very specific. If one of your tests fails, you're going to have a good idea of why it's failing because it's testing a very small part of the code. And that's a good thing. That's what you want from a unit test because it makes it a lot easier to debug. But it comes with a downside of making your tests really brittle because if you want to refactor your tests or refactor how your store works internally, you're going to have to rewrite all of your unit tests. And the cost of maintaining your unit tests is going to increase. So the third approach then to unit testing a store is to actually test a store instance. So we just saw how you can test each of the parts of a store separately. But in the actual app, you're going to combine these into a running store instance. So why not, in a test, create the running store instance and then test against that? Whoa. Crazy. So, yeah, when you're testing like this, you're basically treating the store as a black box, and you're going to interact with it in the same way that your app's going to interact with the store. So you dispatch a fetch items action, and then assert that the state items value gets updated. And this basically treats the mutation as an implementation detail. So you're free to refactor the internals of the store. And that might not be that great with a trivial example like I've been showing you, but when your store gets more complex and you're maybe firing multiple dispatches from an action, it saves you from a lot of tests. You get a lot more coverage for less code. So I'll show you what that looks like. There's 3 steps to testing a store instance. First, you need to install Vuex so you can actually create the instance. And then create the store instance. And finally, test the instance. So step 1, install Vuex. Pretty simple, right? Just call vue.use Vuex. But wait, hang on. This is kind of dangerous because what you're doing when you install a plugin on the Vue base constructor, which is the constructor function exported by Vue, you've changed, plugins can change the Vue base constructor, and that might affect every future test. So when you call Vue use in one test, you're potentially, that plugin's going to change the Vue base constructor, and every future test afterwards that uses that Vue instance that's running in the same test context is going to be using that changed Vue constructor. And for Vuex, this actually isn't really that much of a problem, but it gets really problematic for some plugins that add properties as read-only values. So you can't mock or overwrite those values in future tests. So the alternative is to use this thing called a local Vue constructor. And a local Vue constructor is, you can think of it as an extended Vue constructor. So it behaves in almost the same ways as a Vue base constructor, but it's extended from that Vue constructor. So if you install a plugin on it, you're only affecting that local Vue constructor function. You're not affecting the base constructor function, which will be used in future tests. So that's good. So the way that you use a local Vue constructor is by using this create local Vue function. And you just call it. That's going to return you a local Vue constructor. And then you can just use it like a normal Vue constructor. So you can install Vuex. So I feel pretty strongly about this because, like I said, it's not so much of a problem with Vuex, but it really is with other plugins. So I made a meme to try and encourage you all to use local Vue rather than the Vue-based constructor. Cool, so that was installing Vuex. Step 2 is to actually create the store instance. So normally in an app, when you're creating a store, you're going to do something like this. You instantiate a new store with a config object that combines your state and your actions and maybe modules, mutations to create the store instance. And this works fine, but if you want to test it, it's kind of problematic because in a test you need to create a new store with the same config in each test to make sure that it's isolated. So I recommend moving out your store config into this function to return a new store config object each time you call it, and then create the store like that. And that function is pretty simple. It's just going to return a new object combining your actions, your mutations, and it creates a new state object each time you call it. And that is important because if you don't create a new state object for each store instance, you're going to be sharing that state across every single instance that you create using that original state object. So you need to create a fresh object each instance that you create. Okay, cool. Now step 3 is pretty easy. We just test it. And when you're testing a store, like I said, you're just going to treat it like you would in an application. So in our case, we're going to dispatch fetch items and then assert that the item's value has updated. So if you put it all together, it's quite a big test, but bear in mind you get a lot of coverage from this. So you can see we're doing some setup. We're creating a local Vue constructor. We need to mock API, the API file again, and create the items, create the store, dispatch fetch items, and then just assert that the items value is updated. So that's it. Some people might say, Ed, isn't this an integration test? And I would say, maybe, but but this is called unit testing of Vuex store. So in this case, no, it's a unit test. So the benefit of testing a store instance is that the test isn't brittle, right? So we're free to refactor the internals of the store. And like I said earlier, if you have a flow that maybe you have an action that dispatches lots of other actions in response to an initial call, it could be really useful to not have to write tests for each of those parts and just to test the kind of input and the output of the store, because then you're free to refactor without rewriting your tests. But they're less specific, so if something does go wrong, it's going to be more difficult to find out what the problem is because they're not as fine-grained as unit tests, or when you test each part separately. So, yeah, I guess the burning question is, which approach should you use? And the unfortunate answer is that it depends. It depends on the project, depends on how many people are working on the project. For example, I said earlier, you sometimes don't need to write tests, and sometimes I do that. If I'm working on a small app, like I said, maybe an internal tool, I just probably won't write tests because I'm going to develop faster without those tests. It's unlikely I'm going to go back and do any major refactoring. I'm not going to be maintaining this project for a long time, so I just won't write tests. Sorry? Okay, I don't have my glasses on. I have 10 minutes left. I don't have 10 minutes worth of content left, so I guess I could take some questions. If I was testing an app, if I was working on a project by myself, I'm going to be maintaining it for a long time, but it's just probably going to be me working on it, and it's going to be quite a small app. I would test the store instance because I don't have to write as many tests, but I still get the coverage and I still get the confidence from running the tests that my app's working correctly. And then finally, if I was working on a large app with multiple people on the team, I'd say just test the store part separately, because then firstly you've got like a pattern for everyone to follow. It's kind of easier to say, okay, just test every single mutation in action and getter that you write. And secondly, if you're testing the store instance, it can get quite difficult to maintain as a store gets larger. So, in conclusion, yeah, I'm not really sure. It depends. So, although I have 8 minutes left, that is the end of my talk. But if you want to learn more about testing, if you want 8 minutes more of content, I've written a book that's out now, Testing Vue.js Applications. So, thanks, and I guess I'll take questions for 8 minutes.
Alguém tem uma pergunta, pessoal? Opa, achei uma ali no fundo.
Hi. So, I would like to understand what the real benefit to test the mutations part, because the example you show, it's kind of you're testing how the Vuex should work. Is that, in some case, do you use any kind of logic implementation inside the mutation, just dispatching to the state? Like, I understand like the action is like a really good example. It's like really cool, but just for the mutation part, it's like there is something that gives you back, like the testing of the mutation.
Yeah, so the question is, why would you test a really simple mutation that just updates a state value?
Yes.
Well, I think that you don't necessarily have to. I mean, the main reason that it was a simple test was because I wanted to make a simple example. Maybe I should have made it a bit less trivial. The thing is, if you are writing tests for every part of a store, then you might end up writing trivial tests like that, because if you have a rule where you say, okay, if it's too trivial, we're not going to write any tests, then you're kind of leaving it up to the developer to decide. Different people decide what's trivial and what isn't, and you might end up in a situation where you have a lot less tests than you intended to have, if you do want to unit test each of the parts separately. But yeah, I agree. In that example, that probably wasn't a great example, because, like you said, it's not really testing very much. But it's not testing that Vuex is working correctly, because it's at no point in the test are you actually using Vuex. You're testing that the function does what it's supposed to do. Yeah, so the question was, are there ever any cases where it's more complicated than just extracting some properties from the payload object? Yes.
Mais alguma pergunta?
On the same topic about the mutation, on the second approach, you're not actually testing the reactivity of the store. So I can write a passing test and it still not be working correctly.
Sorry, so you're not testing the reactivity?
With the second approach,
yeah,
the way you mock the function, you're not actually testing the reactivity of the store. So if I made a wrong mutation, I mean, if I have a nested object and I change the property inside the nested object, you know what I mean?
Yeah, that's a good point.
So your test is passing, but it's not actually working.
Yeah, so I guess if you were testing something like an object or an array where you need reactivity to work, then you would have to write a slightly different test.
Like the third approach.
Yeah.
So the third approach seems to be better overall.
Yeah, I think so.
Okay.
Mais alguma pergunta, pessoal? Alguém? Não? Então vou mover para as perguntas online. So Ed, we got an online question about, do you have any tips for writing BDD with Vuex?
Writing BDD?
Yeah.
So, do you mean like writing the tests before you write the code?
No, BDD, Behavior Driven Development.
Right. What do you mean by BDD?
Let me check the question. Yeah, that's pretty much it.
Yeah, sorry. I do know BDD, like where you specify how something's supposed to behave before you write the code, but I don't really know what that would mean in terms of the Vuex store. But So I don't have any tips, is the answer to that question.
Okay. I hope that answers it.
Yeah, probably.
Mais alguma, pessoal? Opa, mais uma. É a última, viu, pessoal? Last question.
Hello. Would you say in order to make your site more testable, it's better to split your mutations, actions, and state in different files and test each one of them separately, or you'd say like to put in one single file and test the whole workflow?
So was the question, should you split the mutations, actions, and guesses into separate files if you want to test them separately? I guess it depends on the size of the store. I personally always split them, but I think that's just a convention that I've been following. Yeah, I think it depends. It doesn't really make any difference to the test that you're writing. That's more like how you're structuring your store. As long as you can import the functions to test, then it doesn't matter.
All right, I guess that's it. Ed,
Yeah?
in the name of Vue.js Summit, I'd like to give you a gift.
Oh, awesome. Thanks.
Thank you so much for your talk. It was awesome.
You're welcome. Thanks.